Carboxylic acids and esters. For the next 7 minutes or so, we will tackle these two groups of compounds. We will learn their nomenclature, how to write and draw them, the simple reactions created, and the applications of the two. Let's start. Compounds that contain the carboxyl group are acidic. They are called the carboxylic acid. Most are weak acids. They are much stronger than phenols, however.
Nomenclature. Let's systematically name some carboxylic acids, so let's have a molecule that looked like this. We can clearly see that there is a carboxyl group right here. That makes the molecule a carboxylic acid. And to name systematically, we do it just the way we name our simple alkanes when we first learn how to name any organic molecule. We look for the longest carbon chain. The longest carbon chain is 4 carbons, so the prefix would be bute. There is a carboxyl group, so instead of calling it butane, instead of writing E, you add the OIC acid. We call this molecule butanoic acid. All carboxylic acid are arranged that the carboxyl group is at the end of the carbon chains, so carbon 1 will always be on the carboxyl group. There is no need to specify and number the carboxyl group. Get it? Let's do another one. Let's say we have something that look like this. Let's put a methyl group right over there. Now, clearly a carboxylic acid. But to name, we just have to find the longest carbon chain. So we have 6 carbons. Our prefix would be hex, so it's hexane. It has this carboxyl group right here. This is hexanoic acid. Take note that there is a methyl group right there. Since we start counting from carboxyl group, it is at the number 3 carbon. So this is 3-methyl-hexanoic acid. Let's say we have a molecule that looked like this. Once again, look for the longest carbon chain. We have 7 carbons. So the prefix is hept, so it's heptane. Be careful, this isn't an alkane, this has a double bond, an alkene. So it's heptene. We're not gonna put the last E here because this is a carboxylic acid. And to specify where the double bond is, we start numbering at the carboxyl carbon. So you could either name this 3-heptane or you could name it hept3n. This is the more typical, the one that you would see because it tells you we have a double bond and it's on the number 3 carbon, goes to the 3 to 4 carbon. This is a carboxylic acid, so instead of writing the final E here for an alkene, we write it as 3-heptenoic acid. Typical applications of carboxylic acid.
One commonly known carboxylic acid is lactic acid, the substance that builds up in muscles during anaerobic exercise. Whenever we move, we use adenosine triphosphate, or ATP, for energy. ATP is created from glucose in a process called aerobic respiration that occurs in every one of our cells. Only approximately 85 grams of ATP can be stored at one time. During exercise, all the stored ATP is quickly used up, and the body has to produce more. However, everyone reaches a point where they cannot breathe in enough oxygen to produce the necessary amount of ATP. Carboxylic acids are not only found in the body but in commercial products. Scientists have discovered that the carboxylic acid beta-hydroxyl acid, or BHA, can be used to create acne medications. It is therefore used frequently in cleansers, liquid foundations, moisturizers, anti-aging hydrating creams, eye gels, and sunscreens. The type of BHA that is used most commonly in skincare products is salicylic acid. Acne is formed when substances such as dead skin cells or bacteria clog pores. BHAs like salicylic acid are able to exfoliate dead skin cells, which speeds up the natural body process of shedding the outer layer of dead skin. This helps to prevent dead skin cells from clogging pores and to smooth rough skin.
Simple reactions of carboxylic acid. Because of their enhanced acidity, carboxylic acids react with bases to form ionic salts. In the case of alkali metal hydroxides and simple amines, the resulting salts have pronounced ionic character and are usually soluble in water. Heavy metals form salts having more covalent character, and the water solubility is reduced. Carboxylic acids and salts having alkyl chains longer than 6 carbons exhibit unusual behavior in water due to the presence of both CO2 and alkyl regions in the same molecule.
Three important classes of acid derivatives are formed by the replacement of the hydroxyl group by another group of atom. An ester can be thought of as removing one molecule of water from a carboxylic acid and an alcohol.
Nomenclature. Esters are another kind of carboxylic acid derivative. From the generic carboxylic acid on the left, we can turn that into an ester over here on the right. The first thing you do is look at this R group on this oxygen. And we're gonna name this R group as an alkyl group, then you will see the carboxylic acid and a carbon chain on the left. So if we're gonna name this ester down here, once again, we look at the R group and name that as an alkyl group. And now we have an ethyl to start with. We could think about that as coming from this carboxylic acid. And we know this carboxylic acid is called acetic acid. To finish naming off our ester, drop the ending for our acetic ACI, drop the IC acid part and add 8 instead. The name of this ester will be ethyl acetate. But if we called it ethanoic acid we could do the same thing, drop the IC acid part and add 8. Another name for this would be ethyl ethanoate. So two different ways to name this ester, but ethyl acetate is more common for this ester. So let's go ahead and name another ester. So once again our goal is to name the ester on the right. And we start with the R group that's attached to our oxygen. Notice the symmetry, we have another one over here. And so we have two ethyl groups this time, so we're gonna write diethyl to start naming our ester. And to finish naming our ester, think about the carboxylic acid portion. So if we think about this portion right here, the common name would be malonic acid. To finish naming our ester, remember to drop the IC acid part and add 8, so this would be malonate. The name of this molecule, this ester, would be diethyl malonate. Typical applications of esters.
Esters of low molecular weight are colorless, volatile liquids with pleasant odors, slightly soluble in water. These and other volatile esters with characteristic odors are used in synthetic flavors, perfumes, and cosmetics. Liquid esters of low volatility serves as softening agents for resins and plastics.
Simple reactions of ester. Esters are produced when carboxylic acids are heated with alcohols with the presence of an acid catalyst. The catalyst is usually concentrated sulfuric acid. Dry hydrogen chloride gas is used in some cases, but these tend to involve aromatic esters, the ones containing a benzene ring. The esterification reaction is both slow and reversible. Esters can also be made from the reactions between alcohols and either acyl chlorides or acid anhydrides.
Thank you for watching this video. If you have any questions, please leave a comment below. If you enjoyed watching the video, hit subscribe.